I have to always write the atomic symbol, and I look first for the primary energy level, and that corresponds to the row that the atoms are actually located in. So to start with, we start in the very beginning. This is the first row, first primary energy level. The first sublevel we come to is S, and helium belongs over here. So 1, 2, that's 1s2, and that's the S sublevel with 2 electrons in it. Number 1, number 2, number 3. Not a column. Columns go up and down. Rows go side to side. Is that where your confusion is? Well, the first row is here. That's what this is. The first energy level in an atom corresponds to that first row on the periodic table in this case. It's down here. We're getting that. We're going to build up to it. Then we got to do 2s. So here's the next row starts with 2s. The second row is 2. This is the S sublevel region. So that's 2s. 2 elements in that as we count our way across. So that's 2s2. And then then we get over here, and there are 6 atoms over there. So in the 2p rank, this is the p sublevel over here. Second row, p sublevel region, there's 6 electrons, and we haven't gotten to magnesium yet, so we've got to do 2p6. And then finally, when we come back over here, third row, S sublevel region, 1, 2 electrons, 3s2. Oh, well, there you go. No, not today. All right. Yes. What now? Because when I'm counting my way up, 1, 2, 3, 4, 5, when we get over here on the 5th element, this is the p sublevel region. But we're still in the second row. So the 2 is the second row. The p is the sublevel region. Well, that's what's represented here. What really is, 2 is the second primary energy level, and p is a sublevel region within that. So if I were drawing a shape, the p would be those double balloons, right? So the actual orbital where these electrons are located are double balloon shapes. Okay? Now, if we're going to do a shorthand version, also called the noble gas or abbreviated version, we're going to take out the noble gas part of this configuration, and that right there is the configuration of neon. Okay, so neon is 1s2, 2s2, 2p6. So we're going to take that out to write our shortened version. So we're still going to write the symbol for the element, magnesium, but now instead of writing all of this, we're going to put in the symbol for neon. So all of that's been taken out, and we've replaced it with that. All we have to do is write this on the end of it. And that's the shortened version, or the noble gas version, or the shorthand version. Let's see. I don't know if we're going to have time or not. Let me come back to it if I have time, okay? All right. Then if I want to write the orbital notation, we're still going to have the symbol for the element, and we're still going to use these coefficient numbers in the letters. So I have 1s. But instead of the superscript, we have 2 electrons in a box to show that they have opposite spins. One is going to be up and one is going to be down. Because 2 electrons that have the same spin cannot be in the same orbital. They have to have opposite spins in order to cancel the you have to have opposite spins to keep 2 electrons in the same orbital, because you need to cancel what? The electromagnetic field, or the electromagnetic repulsion, either one of those terms. Yes.
Wouldn't you keep the S beside that one?
Yes. Okay. All right, then we come to 2s. 2 electrons. The s sublevel only has 1 orbital. And then we're going to go to 2p, and the p sublevel doesn't have only 1 orbital. It has 3 of them. 1, 2, 3. So we got to have 6 electrons. We're going to put the electrons in there as arrows, using what we called in here the school bus rule. And we're going to put one little arrow or student on each seat until every seat has a student, and then we come back and pair them up. Okay? And then we get to 3s, and we have 2 arrows. And that's the orbital notation. And I believe that's about everything we covered in this unit. I mean, so far in this week. Yes.
So, like, with the P sublevel region, you have the 3 orbitals, and then with the S, you have the 1.
Yes.
What would it be with the D sublevel?
Well, you don't have to know that, but D has 10. I'm sorry, it has 10 electrons. It has 5 orbitals.
Okay.
And F has 7, so it has 14 orbitals.
Oh, okay, so you get half of it.
Mm-hmm. Okay. Now, I was asked to do another one of these before we do the test. Would you like me to do another one of these sets before we do the test?
No.
Anybody else besides that one person that wants me to do another one of these? Okay. We have a vote for 2 people. 2 people to do it. That's enough. We're going to do it. Okay. Pick me an element.
Sodium.
Sodium. Well, that's right beside magnesium. Don't you want to do something a little bit more different than that?
Yeah.
Gold.
That's too high. You don't have to go there.
Fluorine.
Fluorine?
All of them.
Well, you don't even have to write orbital notations through this D sublevel, though. All you have to do is do just this part of it. All right, somebody asked for fluorine. I'm going to do fluorine. So fluorine has a symbol of F. Don't write FL. That's a different element. Okay? Okay. First row of the periodic table. That's the primary level 1. We start out in the S sublevel here, where hydrogen and helium, because helium gets moved over from the other side. So there's 2 electrons there, 1s1 and 1s2. So this is 1s2. And then we get down to the next row. That's element number 3. So this is the second row, second primary level. That's 2. 2s. And then we're going to have 2 electrons here and here. So that's 2 electrons up here. And then we get over here, 1, 2, 3, 4, 5. This is the second row. That's 2. P sublevel, that's P. And 5 electrons. So 2, P, 5. Okay? Now if I'm going to do the noble gas configuration for fluorine, I have to identify the next lowest noble gas. Well, fluorine's right here. The next lowest noble gas is helium. So the only part of this that I can take out is 1s2. That's all that can be taken out. Okay? So I can do that. It's, almost not worth it, but we could do that. And we just write 2s2 and 2p5. And that's the noble gas or shorthand configuration, although that's not really short. Okay? Yes?
So with magnesium stands for neon. What does that stand for?
Helium. Helium's the next lowest noble gas below fluorine.
Well, where's neon?
Neon's right here.
Oh.
It's the next lowest noble gas from magnesium. Okay, magnesium's here. Count your way back. 12, 11. There's neon. 10. Okay? All right, let's do the orbital notation now. So we've got a 1s sublevel. We're going to have only 1 orbital in an 1s sublevel, and that has 2 electrons here. Or we need 2 electrons in it because there are 2 there. Then we'll come to 2s. So we have 1 box, 2 electrons. And then we're going to get to 2p. 2p always has 3 orbitals, 3 boxes in the case of an orbital rotation, even if those boxes don't have anything in them. the boxes have to be there once you reach that 2p sublevel or any p sublevel. Yes. Yeah. What now? Always going to have 3. If I were doing the orbital notation for boron, I'd put 1 electron here, and these 2 would be empty. But I have to have those 2 boxes there, even if they're empty. Okay? Yes.
I got a question. How do you get HE right now?
Because this is the orbital or the electron configuration for helium, just that part right there. Okay? Helium's electron configuration is simply 1s2. So I just took that 1s2 out and replaced it with a symbol for helium. Okay? Alright, so fluorine needs 5 more electrons, and you put them in according to that school bus rule we talked about. So we're going to put 1 in each box. That's only 3. We need 2 more. So we're going to pair up 2 of them. And there's the orbital notation for fluorine. Anybody have any questions? Yes.
Do we have to do that middle part?
Yes.
With the, what's the middle part? The 18, not it?
If it's an element in that row, you might have to, yes. Any other questions? All right, if you want a set of test references, you need to get them. You need a pencil. You can have a calculator.